All right, thanks everyone for taking the time to watch this talk today. My name is Peter Bailis. I'm the CEO and founder of Sisu Data, a analytics startup in the human-in-the-loop data analytics space. And I'm also an assistant professor of computer science at Stanford. And today I want to talk about some of the lessons I've learned over the last several years, really not only doing research in, but also productionizing and productizing human-in-the-loop systems. And we'll cover a couple interesting topics here, like what interfaces do users prefer and what unifies these interfaces in our experience? How do we set expectations with our users? And given some of the limitations of ML, especially on top of structured data, how do we work around these? And maybe most broadly, how do we design for educating users and basically empowering them when they maybe haven't had exposure to ML or we're giving them a new interface? And well, I won't have all the answers. Definitely spent a lot of time in this space, and my goal is to talk a little about some of the history behind the decisions we've made, as well as some of the lessons I think are actionable and perhaps interesting for the research community. So starting with a bit of ancient history, my start of this really full-time pursuit of human-in-the-loop data analytics came in 2016. I spent a couple months previously at MIT as a postdoc while I was waiting to join Stanford as a professor of computer science. And this was meaningful because I realized I had 7 years before Stanford threw me out to basically work on something big. And I started thinking a lot about some of the tech trends in the area and wanted to take a big swing at a particular space. And time and again, as I continue to learn from the greats of data, I kept coming back to this quote from Herb Simon, which is, "In an information-rich world, the wealth of information means a dearth of something else, a scarcity of whatever it is that information consumes. What information consumes is rather obvious. It consumes the attention of its recipients." So, in a world in which, and here I'm going to use some slides literally from 2016, you can see our cool Stanford InfoLab logo here. In a world in which data volumes keep growing up and up and up, and we had this explosion of data volume, especially with things like IoT, there's really no end in sight from data growth. And our natural question was, given as Herb Simon says, information becomes increasingly common, attention becomes increasingly scarce, how do we actually make this information more useful and more usable to users and really prioritize that limited human attention? Some of our friends at the time were saying only 6% of the data in their warehouses was even being read. And again, thanks to Sam Madden, who hosted me for those couple of months in Cambridge, has this cool company, Cambridge Mobile Telematics, runs a smartphone app telling you, are you driving well or not? They want to know, is the app actually behaving well on every platform? Well, if you're on the Android device ecosystem, there were over 24,000 different Android device types even in 2016. So if you spent even 1 second per combination of, say, Android devices and API releases, you'd need 7 days end to end, no sleep, in order to figure out things like iOS beta 1-5 had a buggy Bluetooth stack that prevented our devices from connecting to the in-car devices. And this is kind of a real world example where even someone like Sam was having difficulty doing this because, again, where do you look and why? And this came back to this ultimate question that we continue to see, again, what Herb Simon had kind of predicted so long ago, which is that really we're missing systems to winnow and really bring this data volume down to highlight what's interesting and salient. And what we really felt, and I really staked my junior faculty career on this idea that we could build systems that automatically prioritize this end user attention. Now, natural question for this crowd, maybe not super surprising, but at the time we got a lot of feedback that went something like the following, which is essentially, how should I query for outlying device readings? And in Spark, you just say, okay, great, you can write a UDF for that. Right? In fact, I get the comment a lot. I'm sure many of you have gotten this in your reviews in the past. It's like, oh, well, you can just do all of this using UDFs. And the answer is you can, but if you're a user who's actually trying to do something important or interesting with their data and are trying to get about their day, don't want to take the time to read a stats textbook to learn about unsupervised density estimation, well then, you're basically building all this stuff from scratch. And we took a big swing and started to build out a system that was essentially this idea of executing cascades or increasingly expensive and increasingly precise operators to essentially combine statistical methods for transforming, classifying, and aggregating data in order to actually highlight what's meaningful to a given user. And to give you an example what this looks like, we built a UI, which is shown here. You kind of identify, okay, I care about, say, application version, hardware make, and hardware model, and I want to know, what's affecting battery drain. And we have this web UI where you could download this and run it, and you can actually get these groups. In this case, there's this application version 50, hardware model EM-IE180, hardware make MDOR, where the battery drain is actually a lot higher than usual. And this was pretty simple. It was, running some of the early prototypes we had built. They built on a bunch of really cool ideas that this community actually worked on. Some of the work like Eugene Wu's Scorpion, and even some of the earlier work on coming out of IBM with Fagan on multi-dimensional databases. So there's a bunch of stuff that kind of went behind this and scaling it up that's not as relevant to this talk. But what was interesting to me was the fact that we put this kind of really simple UI online, gave a bunch of talks about it, and people would actually run this thing on their laptops. So I'll just give one example. We essentially had a large battery manufacturer download this thing, put in all of their device readings from their battery readings from their fleet. And you can see here, we started rolling a new firmware version. Only a small percent of the fleet got upgraded. The subs of the systems didn't behave as expected. I ran macro-based as a matter of routine, and up came these systems, which just got new firmware a few hours back and acted weirdly now. So it was kind of interesting to see, and we had some really interesting users, big Fortune 500 companies, basically just from having a very simple UI, the one I showed you here, and essentially giving someone something to connect to structured data and actually get useful results back in a way that, again, the conventional OLAP or BI tool, you'd be entirely driving this process on your own. If I kind of give the high level lessons, these aren't as interesting as I think some of the later ones. I think there's a huge opportunity for this continue to prototype really fast. One of my favorite books that was really influential was this idea of a lean startup. Naturally, as a researcher, you're not necessarily commercializing your work, but it's helpful to understand how quickly can I get something to market and test it out. I remember sitting on a panel, listening to a panel about HILDA a couple of years back at Sigma, and I asked the question, what's going to be the outcome of all of this work in HILDA? Is it going to be 1,000 algorithms, or is it going to be a couple systems? And there was actually split on the panel, but after my experience in this space, I would strongly encourage people, build systems, build tools, make them really crappy, be really scrappy, and get your users fast. You don't have to be in the middle of Silicon Valley to do this. There's a ton of people on campus who want to do this. I'm not going to touch on these too much, but would love to follow up later. We found kind of two interesting things. One, very few people outside of IT actually cared about streaming or low latency applications. So most businesses care about maybe daily or weekly trends. We found that data sets are either huge, like enormously large, or if they were human related, like customer data or having to do with purchases or transaction volumes, it's less than 1 billion users typically. So we basically shifted our focus over to these questions around, how do you do batch operation very quickly? How do you scale this stuff up? And how do you make it interpretable? We have a bunch of papers like Sigmon and VLDB on streaming, which is really fun. But it turns out the really hard stuff in terms of what actually made users pick up that macro base and use it all had to do with the fact that we do this at larger scale and speed and use all of their data, and also making it really easy to use. Which brings me to my first kind of key lesson, which was specifically on interfaces. So when I think about HILDA and human in the loop, it's all about how do you interact with data and how do you put your users in a way where you can both understand what they're doing and you can also get their feedback, ideally implicitly. And we had a range of debates, even from the start of the macro-based days, how should we provide this set of interfaces? And honestly, if you read the Cider paper where this figure is pulled from, we basically just didn't pick. So we said, you've got a web UI, which can spit out a script. We had this kind of really cool chain-based data flow configuration language. We can write these pipelines. Then we had you can write arbitrary Java or C++, which basically is your escape hatch. And while I do think escape hatches are helpful for programmers, this kind of range between point and click and SQL or do this as a library or service have very different user profiles. So for example, analysts want something they can point and click on. And I'll give an example of this. So at Microsoft, we actually embedded Macrobase inside of an existing dashboarding tool that basically tracks Skype and Xbox and a bunch of product telemetry. This is joint collaboration with a bunch of Microsoft folks at a retreat for a Dawn project. What they did is they basically had a point and click UI, and then essentially you could click this button next to something like this is the average latency of a Cortana operation. You click Analyze Chart, So there's the human interaction. We analyze the data using AI, very cool, and basically spit back, the results of say what Macrobase would say, which is, there was an outlier here. It's actually disproportionately correlated, or depending on your interpretation of causality or influence functions, it's related to the speech EAP crowd environment. And here's your average, again, just like we saw before in the Macrobase prototype. And then here's the outlier. And we came with a couple different ways to go and do this. These analysts are great because, again, they're the ones who are in the tool who really understand stuff. But we also wanted to understand, well, how do we get to like data scientists, and how do we get to more complex users that want to actually run scripts and write scripts. And we actually wrote, and this was part of a VLD paper over the past couple of years, maybe last year, where we basically wrote like a special SQL operator for this, where you could just run, select star from, tell me the difference between these two tables, compare according to some difference metric, and then you get basically a table back. And this was cool in some sense in that it actually made like writing queries and also writing papers pretty interesting, because you can like push these types of operations through joins. You don't have to denormalize your tables and so on. But what we ultimately found is that like the right answer to this which interface question depends a lot on who you want to target, right? So for something like from a research project perspective, we found that the only people who really could consume like this thing as a standalone service were really big companies, which is essentially what Microsoft did. And they integrated it into a point-and-click application, but they didn't want our point-and-click application. For SQL, data scientists love this. We wrote this VLDB paper and VLDBJ paper. You can take a look. It's pretty cool. It's actually the only paper I know that has Microsoft, Facebook, and Google on it. And they were really great collaborators. But we found that, honestly, a lot of the folks who wanted to use this stuff at scale, like you'd have to re-implement it inside of Presto, re-implement it inside of another database. And then, the query like execution pattern really demands, in my opinion, a different database, because you're doing this irregular parallel group bys and joins, and it's pretty gnarly. So we basically stopped doing this on the research front. Also, taking the like SQL parsers and stuff is really gnarly. We've had other collaborators basically develop this as a standalone library. Honestly, if I had to do this again and choose between SQL and library, I think libraries are awesome for this sort of stuff, but you don't necessarily control the end user experience. And essentially what we found in our experiences with working with kind of everyday analysts who are really the data enthusiasts, to use what Pat Hanrahan would say, we really like these point and click users, these folks. And that's why we started Sisu essentially. I'll get more on this later, but we essentially found, look, it's very hard to build great interfaces in academia. You got an IRB approval for a ton of stuff, and you can get great designers in the real world. And but I personally believe that point and click analysts are really where the heart of this community can have major impact. And the big question is, how do you get there? So one natural question here is, this sounds kind of like we've got three different options. What's really going on? Well, I would claim actually, and this is a theme we'll come back to, one of the really underappreciated or easy to miss sort of themes that unifies these, which at least I missed when I first started looking at this, that no matter how you do this type of data exploration and data analytics or proactively suggesting what someone looks at, no matter if you run this as a service or SQL or a library or just do it as a point and click service, all of these different approaches essentially use some concept of a business metric, right? So just to give an example, like if you wanted to build a dashboard in Tableau or build anything that powered a Tableau replacement, every single one of the dashboards that you're looking at have to do something with metrics, right? They have to do something with business metrics that people care about optimizing. And this raises a very natural question, which I think is a really interesting research question, and one that I've been studying for a long time. Could you build an entirely new human loop data analytics platform centered around metrics as opposed to just dashboards? So this thing's pretty static. I'm going to pre-configure it. I'm going to have to go and look, and essentially, whatever I ask for is what I get. But in the modern era where deep learning and machine learning is taking over everything, if metrics are the commonality here, why couldn't you build a service-based platform around metrics, or a SQL-based platform around metrics, or a point-and-click platform around metrics? And that's essentially a large part of what we're doing. But I think this is a really key lesson. focusing on metrics as opposed to visualizations is really key. People look at visualization recommendations, very useful, but what actual businesses care about on a day-to-day basis is their business metrics. Revenue, churn, margin, volume. Any modern team, even a lot, honestly, in the Fortune 100, Fortune 500 space, they run not just their P&L off of profit and loss off of these metrics, but they run their teams. And so I think that's a key lesson that we'll come back to. So metrics are a great unifying interface, but there's a lot of ways to get this type of data exploration stuff out to users. And the key one that I'd say is just building something as opposed to just writing more algorithms. All right, so big question then is, setting expectations. So if we want to use ML, for example, to answer this question, what metrics should I go look at? What's going on with my metrics? There's this real mismatch between research and enterprise, right? So enterprise companies essentially want machine learning, they want auto ML, and there's almost this unfair conflation where, you hear about, they say self-driving cars and all the great changes that are happening in ML, and they say, well, why don't I get a self-driving marketing department? Well, at least if you care about structured data, as I do, the funny thing about deep networks, they don't actually help much with structured data. So, one of my favorite examples of this is this paper from Google over the last couple of years. It's in Nature Digital Medicine, made a bunch of news. They talk about how deep networks have amazing accuracy on predicting things like inpatient mortality, 30-day readmission. Someone on Twitter pointed out, logistic regression performs about as well as deep networks. And they didn't even train on against GBDTs. So it's unclear if GBDTs would have even done better. But I call this out because there's no real panacea when it comes, especially to many enterprise applications and structured data. It's not like you just throw in XGBoost and you're done. You're going to get maybe in the 90% accuracy. And I would claim that most UX patterns, at least for a low touch, almost consumer setting, are really not like one and done. Like when I asked Google to prepare for an upcoming talk, it doesn't give me the slides that I need in order to make the talk, right? It tells me about the venue, but it doesn't tell me much about what's actually going on. And, it would be insane if, essentially Google could prep my breakfast, book me an Uber, cue my playlist, and get going. But the reality is we all kind of know from a consumer perspective that ML and interacting with ML is not this good. I mean, Google knows more about me than probably any other service, right? It knows when I wake up, it has my mobility data, it probably has access to my bookings data, it definitely has access to my Spotify data. Like, it should be able to do this, all the information is there, but because there's not demand for essentially this very specific application where we can feature engineer the crap out of this around making breakfast and booking an Uber and queuing playlists, find out revenue attached to that, Google doesn't do it. And I think this is really interesting. It's not just this one and done, I've got my model, now I'm all done, especially when you do complex and nuanced business workflows. You have to rethink that actual user interface. And my favorite example of this, when I go talk to business users, I say, look, do you remember the old Google search? Google got rid of this to optimize their ad placements with the type ahead feature. But if you remember, Google used to have two different buttons. One was the Google search bar, just do a regular search. And this other one was this I'm feeling lucky button. And the I'm feeling lucky button essentially was like, you are lucky if you get the right result on the first try. And no one really upset about removing this I'm feeling lucky button because it was kind of the joke. It was like tongue in cheek. And I would argue that when we think about human in the loop data analytics and ML more generally in a more enterprise context, especially with structured data, but even more broadly as we think about building applied data products in production, I would argue that recommendations are probably the number one machine learning user experience pattern, right? It's not that the machine does everything. I would actually claim that recommendations with a human in the loop are where we've seen the most success. You see this in Google search and AdWords, for better or worse, the Facebook newsfeed, Twitter timeline. I sit down and watch Netflix at night. I get a bunch of recommendations, but I don't get like a Clockwork Orange style, Peter, you are watching Tiger King. You cannot change the channel. Amazon product recommendations and so on. And so a very natural question then is towards this question of, can we create a metric-oriented analytics platform? We could very reasonably draw the conclusion we could build some metric-related recommendations. So this is essentially the realization that brought me in recent history, say over the last 2 years, to really start Sisu and to leave academia to go and work on this problem full-time with a crazy team. So briefly, for me personally, we had seen this kind of rapid adoption among some really big companies and also some really small companies, and it was really hard to hire great engineers and designers in academia. I tried. I love Stanford, but it's just not possible to hire the same type of talent you can go hire in a private market. In addition, very few teams, despite the interest in human loop data analytics, very few teams actually mix both engineering and design as kind of first class primitives. And so what we essentially found was, look, we can raise way more money than it would be ever possible to in academia. You get a ton of leverage and you choose the people you work with, and basically went to town. So to kind of give you an example, and this is really, for the academic audience, kind of how you think about talking about this type of platform for a real business customer. I'm going to show a quick example that my chief revenue officer and I basically spent with a high-level exec at a retailer last Friday, essentially talking about how we talk about human loop data analytics, just to give you an example of where we landed. And then I'll talk about some final design patterns. So we talk about CSU as being proactive, right? It's all about being proactive with your analytics. It's not reactive like your dashboard, it's proactive in terms of telling you what's going on. And you basically say, look, it's hard to keep pace in retail, right? You need to consistently figure out how to sustainably and consistently deliver new products, so customers continue to engage and contribute to lifetime value. Wow, lifetime value. That is actually a key metric. That's like a buzzword if you're in retail. That's a key metric that these people care about. Oh, wow, yeah, it is hard to keep up with my lifetime value. Oh, well, this is why we started CSU. So that for all of your most important metrics, whether it's ROI on advertising or average order value or same-store sales, we can help you understand why these are changing. And the reason why it's so hard to do so is that from an analyst perspective, bells should be going off here. This is basically the Herb Simon thing. There's too much data. There's not enough time. We don't have the time to get answers back. We don't have enough time, and we aren't getting answers back quickly enough to make effective decisions. We aren't confident the answers are correct, and they're not clear enough to drive action, right? And we say, oh, this is what all the analytics leaders, which is true. It's what all the analytics leaders we talk to actually have pains with. And, at best, you're basically squinting at the data, right? So, what happened with this bar chart? Why is this bar higher than this one? Why is this bar here? What bars am I not even looking at? And essentially, decision-making is reactive, slow, poorly informed, yada, yada, yada. And then, okay, great. This is what CSU does. We're a new engine that helps you understand, what's working for your business and why these are changing. So basically, it's all about the why in your metrics. The metric is this first-class primitive. And again, thinking back to Herb Simon, hopefully be proud. It's about speed, comprehensiveness, and proactivity, really turning things on its head in terms of getting to the why. And this sounds kind of like fluffy maybe to many people. This is a research talk, but it's actually real. Like there are real teams using a ton of legacy platforms that actually don't know what's driving these key metrics. And by putting this type of platform in front of them, we've been able to land real customers and use cases like Samsung in terms of what's actually, who's upgrading their new phones and so on. And so in a nutshell, like this idea of metrics related analytics recommendations, our starting point for CC was like, why is this metric changing? What's the key driver behind this metric? And we found that this positioning around why really hit to the heart of what business users care about from their human and loop data analytics applications, which is look, I'm in the loop because I care about my business and I'm looking at some metrics. So tell me why it's changing. Now, the third lesson, the final lesson I want to cover here, which is kind of interesting, is that actually building that out is highly non-trivial, right? Because there are really significant challenges when you're dealing with a line of business analyst around educating them, what's actually going on, providing context when you do give them a result, and actually integrating into day-to-day workflows. All right, so the first thing I want to talk about is basically user education. So how do we actually tell users what's going on? And we have this principle that we found very helpful, which is the idea of a low threshold and a high ceiling. So in this case, what we want to do is understand why is session duration changing, why it declined from last month to this month. And we give users a very simple and intuitive, easy to understand, okay, where region is Canada and show us Stranger Things, session duration increased by 61.1% month to month, which had the net effect of increasing the overall session duration by almost 1.2 minutes. So we're essentially saying, here's the lift attributable to Stranger Things in Canada. Naturally, as a user, I want to understand, well, what's going on here, right? Tell me more about this particular cohort. And essentially, everything in CC lets you incrementally peel away more and more context. So I can click on, say, this first fact, as we call them in CSU, and I can actually get a ton more information about, what is exactly going on here? What is that change in average? What is the change in the number of rows that match here? What does this look like visually? And we make it very simple for people to incrementally get more and more data to run more and more analyses. But again, making it super simple to understand initially what's going on. That's a low threshold. And let the power users essentially go very deep. So another really helpful principle is this idea about letting the data speak, or basically telling people why they're seeing a given result based on the data that we have, and kind of contextualizing every result we show to a user. So in this case, if a user wants to know, what's going on with Canada and Stranger Things, in addition to getting some like transparent statistics about why we're showing this and how this effect was calculated, we actually give users, this is one of the top requests in our early beta experiments, which is like, why am I not seeing only Canada? Like, what if I just look at all of Canada? What's the impact on just Canada? What's the impact if I just look at Stranger Things? Why is it that when I see both of these variables together, there's something different? Or if I want to look in Canada and I want to look at, say, different shows like Cupcake and Dino and Happy Jail and Street Food, what should I do about this? It may be the case that I've driven a ton of traffic to Stranger Things. I actually want to prioritize, say, other segments like Happy Jail and Cupcake and Dino and other service formats. And so this idea that like just showing someone the why isn't enough. You need to make sure that they understand the full context around what's going on, which we like to say, let the data speak, or speaker for the data if you're a Ender's Game fan. And then finally, the big one here, this is kind of a homage to Joe Hellerstein, in that he always talks about the rate of change of the schema is much, much slower than the rate of change of the application. Well, here I claim that like the schema, the fundamental layout of the data, is one of the things that changes the least. You add and remove columns so rarely in a database, like maybe once a quarter, once a year. The rate at which change most businesses operate, even though digital, is like on the course of a day, maybe a week, sometimes a month. But in a modern system, data is constantly changing. And so another thing we found that was very helpful that users really benefited from was this ability to be able to subscribe and say, look, my schema is still the same for this metric, the session duration metric. So every time there's a change in, say, average session duration, where there's any new factor that appears that's affecting my session duration by more than, a few minutes, right? Tell me about it. And what this allows us to do, and this was kind of like the holy grail for me in deciding to start this business, was, we can essentially go in once and configure an objective, or an analyst will configure an objective for a business user, because the data is constantly changing, but the metric is defined once, and the schema, which defines all the attributes you might care about, is also defined very rarely. We just continuously track the same analysis you can continue to run, and just tell someone whenever something changes, which is really interesting. And kind of in total, I know these are maybe very simple, but these took us a long time to iterate in terms of how do we educate users on what this new capability can do. Make it really simple, but let them go very, very deep to understand. In terms of understanding, the best way to explain what's going on is not to explain the nuts and bolts of an algorithm. It's actually let the data do the talking by showing them comparisons and alternatives and giving them full context around what's going on, right? We never mention the actual ranking and relevance measures that we're using. We're instead telling a story using alternative statistics and related facts. And then finally, by making this part of someone's day-to-day workflow, we exploit the fact that schema is one of the slowest changing parts of the business, and the data is one of the fastest. So coming back to our initial impetus from Herb Simon, I think that this shift towards human loop data analytics has this huge opportunity in the context of taking that limited resource of human attention, in our case at CSU, it's the analyst attention, and making it more and more prioritized and more valuable. And if I leave you with kind of three major thoughts here, I'd say human loop data analysts, if you're going for data analysts, they care about business metrics. They don't care about visualizations. They don't care about dashboards. They don't care about reports. They care about business metrics. And I would argue that you can design an entirely metric-centered platform as an alternative to manually driven BI. I claim that BI interface and interaction model hasn't changed in the last 30 years. To get there, ML is good, but it's not great in enterprise settings. So this idea of recommender-oriented interaction patterns that are familiar to users, they're really useful, and they're actually achievable to get good quality results. It's pretty hard. You got to do a lot of it on scale. There's a lot of tricks and tips, and that's why Google still is the best search engine in the world for unstructured data. But this interaction, as opposed to telling someone what to do and removing them from the loop, is substantially easier. And finally, I claim that fitting into everyday workflows is key to getting deployed. So, this requires a lot of new design patterns and thinking for educating users on what's going on, for being transparent on what's going on in the hood without resorting to technical language, and for keeping up with data as it continues to update. So this is joint work with a bunch of awesome people, collaborators at Stanford, Google, Microsoft, CSU, Facebook, and also a bunch of teammates at CSU as well that I'm speaking on behalf of. I'm really excited to take questions, and I'll just mention, if this sounds fun, I'd love to work together. I mean, we're hiring basically, despite the slowdown with COVID, we're hiring across the stack, full-time engineers, researchers, interns, professor interns who want to come for the summer. Let me know. But I think that this is maybe one of the best times in the history of data for human loop data analytics. There's more data than ever, and we're taking a big swing. This is me putting my shoulder to the wheel. So thanks so much for your time.